Hello, everyone, and welcome to today's presentation on the latest advancements in quantum computing. I'm excited to take you through this fascinating topic. Let's dive into how quantum computing is set to transform our future. To start, let's briefly discuss what quantum computing is and why it's so important. Unlike classic computing, which uses bits as the basic unit of information, quantum computing uses qubits. This allows for much more complex calculations at unprecedented speeds. Today, we will cover the basic principles of quantum computing, recent breakthroughs, potential application, challenges, and future directions. Now, understanding quantum computing. Quantum computing is a type of computing that uses quantum bits, or which is also called qubits. Unlike classical bits that are either 0 or 1, qubits can be in a state of 0, 1, or both simultaneously, thanks to a property called superposition. Another critical property is entanglement, where qubits become interconnected, meaning the state of one qubit can depend on the state of another one, even over long distances. These properties enable quantum computers to solve certain types of problems much faster than classical computers. Let's delve deeper into these principles. Qubits are the fundamental units of quantum computing. Superposition allows qubits to perform multiple calculations at once, while entanglement creates a strong correlation between qubits, enabling faster and more complex problem solving. Together, these principles enable quantum computers to process information in ways that classic computers cannot. Now, let's look at some recent breakthroughs in quantum computing. In 2019, Google announced they had achieved quantum supremacy, where their quantum computer solved a problem that would take classical computers thousands of years. IBM is also making significant strides with their development of quantum processors, pushing the boundaries of what is possible. Other companies like Delta Wave and Rigetti are also contributing with innovations in quantum annealing and hybrid quantum classic computing systems. The potential applications of quantum computing are vast. In cryptography, quantum computers can break traditional encryption methods and create virtually unbreakable codes. In medicine, they can simulate molecular interactions for drug discovery. Quantum computing also enhances AI by optimizing machine learning algorithms. Beyond these, quantum computing can revolutionize material science, logistics, and financial modeling by solving complex problems more efficiently. Let's look at specific case study Google's achievement of quantum supremacy. They developed a quantum processor called Sycamore, which solved a complex sampling problem in 200 seconds, a task that would take the most advanced classic supercomputers about 10,000 years. This breakthrough demonstrated the immense computational power of quantum computers and highlighted their potential to tackle problems previously thought to be unsolvable. Despite these advancements, several challenges remain. Technically, quantum computers face issues with error rates and maintaining qubit stability, known as decoherence. Practically, the technology is costly and complex, making it less accessible. Additionally, there are ethical and security concerns, particularly around the implications for data encryption and privacy. Looking ahead, research and development in quantum computing continue to advance rapidly. Scientists are working on improving qubit stability and error correction, making quantum computers more practical and scalable. Predictions suggest that in the next decade, we might see quantum computers solving real world problems in various industries, transforming technology as we know it. In conclusion, quantum computing represents a monumental shift in how we process information. Its principles of superposition and entanglement enable it to solve complex problems far beyond the reach of classical computers, which challenges while challenges remain, the ongoing research and recent breakthroughs suggest a bright future. Thank you for